and those provide a long-range surveillance source. Those are typically 250-mile radius systems that provide high-altitude coverage of aircraft en route. Then we get into the cooperative surveillance world, where we have beacon interrogators. It's a little bit more sophisticated form of surveillance, where we send up a coded signal to aircraft avionics, which interpret that, and then send back a reply, which includes identity and altitude information. So we get more information, more precise information out of these systems. They're cooperative because you need to be able to have the equipment on board the aircraft to be able to use this surveillance type. We have a number of variants listed there. We also use, more recently, we've implemented what we call wide area multilateration system, which is a different type of cooperative surveillance where a distributed network of ground stations receive transmitted information from aircraft and can multilaterate to determine the position of that aircraft. One of the nice things about wide area multilateration is you can use the existing ADS-B ground stations to perform a multilateration function, which provides a diverse and complementary form of surveillance. And then finally, ADS-B, the newest and what we consider to be the preferred source of surveillance for use in U.S. air traffic control. And we have what's called service volumes. So we have 318 service volumes throughout the United States, and that's just a volume of airspace whereby we have receipt of ADS-B information and a service delivery point. So that information is then delivered to a service delivery point, which is typically an air traffic control facility. And then we combine all this information into what we call a fused product. So we have the long-range radar, short-range radar, multilateration data, and ADS-B, and it's all being combined in our air traffic control automation system. And we have one for the terminal area and one for the Enroute environment. The terminal area is called STARS, and the Enroute is called ERAM. But both of these perform a similar function of receiving all this surveillance data, providing a fused surveillance picture out to air traffic control for their use. And then nice thing about this, there's plenty of advantages to doing things this way. You get the best of all of the different surveillance sources, and you get a high accuracy and high update rate surveillance product. You also have a resilient network built in that if you lose a radar system, you still have a full network of surveillance sources feeding that automation platform to provide to still provide surveillance. You don't lose it just because you lose a single sensor. So that's all done in what we call fusion, and a fused surveillance product is delivered to air traffic control for their use. And this is a picture of what the STARS display looks like. Those blue circles there indicate that we have a fused surveillance product. In other words, all the available sensors are feeding in to provide the best estimation of the position of that aircraft in every moment, updated once per second. Those blue fading dots there signal the area in which that aircraft has been. So it's a trail, so you can get an indication of where the aircraft has been. So there's quite a few significant advantages to doing things this way. I'm just going to hit on a couple of these that have been noted by our different air traffic control facilities. A place called Boise in Boise, Idaho, TRACON, was a place where we introduced fusion, and what was interesting about it in this location is that there was a significant amount of area that we didn't previously have any surveillance coverage of that we now currently do. So this fusion of surveillance products permits controllers to see aircraft in areas where they were previously unseen, and aircraft are now controlled. We're controlled using non-radar methods, can now be controlled using radar methods. So we can now see where these aircraft are, so we can have better use of the airspace, and we can have a better safe picture of really all the air traffic out there where we really didn't before. A place called Northern California TRACON implemented fusion. And they were able to redesign their airspace so controllers were not limited to working the airspace because of radar sensor coverage limitations. NCT, or Northern Cal TRACON, was able to streamline procedures with the overlapping Enroute center to further increase operational efficiency. With multiple radars interrogating the same aircraft, the loss of an aircraft data block over individual radar sensors no longer occurs. So in this case, you're able to get a better use, a more efficient use of the airspace. And at Dallas-Fort Worth, Fusion was implemented, increasing controller display update rates and virtually eliminating any aircraft track coasting events caused by surveillance gaps. So if you have a gap in surveillance, those tracks will coast through that and sometimes will be dropped. And now they have a complete continuity of tracks throughout their entire airspace. And all these things are significant enhancements to the ability of the air traffic controller to do their job. So what we'll do now is just talk specifically about the ADS-B system and how we implement it in the US. So just as an overview here, the ADS-B system. So you have the aircraft there in the middle there, determining its own position using GPS or other onboard navigation equipment, and then broadcasting that position and other information as well, not just position, but a rich data set of information regarding that aircraft is broadcast out regularly. So not only do you get the benefit of other aircraft around, that aircraft can then see that position and have knowledge of that, the presence of that aircraft, but the ground network can receive that information and then relay that to air traffic control. So that is kind of a snapshot of how the system works. You do get more accurate information. You get more different types of information that are useful in different air traffic control applications. And you get that information all more frequently, all of which produces a more accurate air traffic control system. All right, since this is not an engineering class and I don't intend to teach an entire wiring diagram on ADS-B, I just put this one in here just to emphasize one point. It may not be obvious that what we don't do is we don't just receive an ADS-B position report and feed that over to air traffic. We have a very complex system. The SBS system itself will receive that information, but also many rich sets of data come into there. You get weather data, you get other radar data, you get GPS constellation data. It all gets fed in, and there's a number of improvements and products that can be done when you have that information fed into it. One of the most important things that we're able to do with it is we're able to compare to, say, radar data and throw out an ADS-B position report that's considered to be not valid. So this is a particularly important, it's something that we really focus on in the US, the importance of correct position being fed to air traffic. So we go through an extensive validation process to make sure that that information is valid. And there's a number of reasons for that. One is you don't want a spoofed position to be fed to air traffic control, which could be a dangerous, hazardous and misleading information. There are also times when ADS-B broadcasts the position incorrectly for whatever reason. You have malfunctioning avionics, and it has happened in the past where that information is fed to air traffic control. We now have a very sophisticated validation process which will throw that information out if it's deemed to be inaccurate. And we do that by comparing to other radar data, comparing to other position sources, doing other things like sanity checks based on where that aircraft is relative to radios and range to those radios and so on. So we do highly value that the importance of validating information before it's presented to air traffic control. You'll also notice there's some other products that are generated here, which I'll touch on later, including traffic information and flight information services, which are other benefits of the system that are provided to various users. Okay, and to just touch on this, I'm not going to spend a lot of time here, but just mention that on the top left here, you have the ADS-B system, which is used for separation services. You also have these other services called ADS-R, which is rebroadcasting of surveillance data on the two different links that we use in the US. We also have a traffic information broadcast service where we can broadcast up all the traffic that is in the vicinity of an aircraft. And then we also have flight information service broadcast, which includes lots of products like weather data or other pirate reports, NOTAMs, and other important flight information that's valuable to a pilot. All right, and just to talk about the rule a little bit, I'm not gonna read the words here, but if for those who are interested in what the actual ADS-B rule says in the U.S., this is a summary of that text. As of January 1st, aircraft in what we call rural airspace are required to be broadcasting ADS-B data, and they must do so at all times. They can't turn it off. It applies to all aircraft operating in rural airspace. And what we consider to be rural airspace, so Class A is rural airspace, so that's above 18,000 feet. From 10,000 to 18,000 is also rural airspace. In that case, we actually can use either of the two data links. And also Class B and Class C around our busier airports. Those are areas in which aircraft are required to use ADS-B, as well as over the Gulf of Mexico from 3,000 to 10,000 feet, and I'll touch on that a little bit more in detail here in just a minute. So, but basically that's the rule. If you're in those airspaces, you are required to have ADS-B. Just to give you an idea of what that looks like in the U.S. Well, the Class B is red there. Class C is yellow. There's a lot of space below 10,000 that is not rural airspace. There's a lot of places in the U.S. that you can operate without using ADS-B. There's quite a few states in there that you could traverse below 10,000 and never have to have ADS-B equipped aircraft. So the goal was never to equip everyone in the U.S. We needed to be able to equip those that use the busier airspace in the U.S. So we use, I mentioned service volumes before. We have ADS-B service volumes as indicated by those cyan circles and polygons. Basically, wherever we have radar coverage, we also have ADS-B. And in some other areas where we don't have radar coverage, we also have ADS-B. So it's kind of radar areas plus. And we do that through this network of many ground stations. So there's 634 ground stations and a total of 318 service volumes. Also notable is that we don't own any of that equipment. So all those radio stations that I just mentioned, we don't own or maintain any of them. We buy a service from a service provider. So basically, we ensure that that data that we receive at the service delivery points does meet our performance requirements. But we don't have to go out and maintain or tech refresh radios. That's the obligation, the requirement of the service provider themselves. So it's a different way of doing things. It means that we don't have to have the technicians going out to maintain all that equipment. We put that on the contractor, and it really, in a lot of ways, simplifies the operation of the system in the U.S. And for us, it was really the best way to do it. All right, so what we're going to do now is take a little pause here. We'll do a Q&A session, and then I'll resume the rest of the presentation.
Great, thanks very much, Dan. I'd just like to draw people's attention to that Pigeonhole platform that we're using for our questions and answers as part of this webinar. If you go to the chat function on the Teams meeting here, you will see there's a hyperlink to access Pigeonhole, and you can see that the passcode is NSS Conference, or you can just go into your web browser and just type in pigeonhole.at and use the passcode the NSS conference as well. So it might just give people a minute or two to put their questions through on that first. Dan, would you potentially be happy to play the video that you have in the next slide while people maybe consider a question or two they might like to ask?
Absolutely, and I'm going to do my best to get that going. And just to introduce this, and it will take a minute to load up, but this is just a testimonial. It's a very short video, less than 2 minutes, that where you can hear from some pilots in their own words as to what this system really means to them. So.
Wow, there went a Cessna right at my altitude.
Hugh McElrath flies across the entire country now and then. That's a lot of lonely miles. But the moment he takes off from College Park Airport in Maryland, McElrath will be in rural airspace, requiring ADS-B out. He hardly has room in the crowded cockpit for a sack lunch, but in crowded airspace, he says he can't afford to skimp on avionics.
This is an extremely crowded area, and I want to be visible to all the other traffic and to have the potential to have greater visibility on the traffic that's around me and the weather and all the other stuff.
Keeping an eye on College Park Airport is manager Lee Summer, an early adopter of ADS-B, years ahead of the FAA's January 1, 2020 mandate.
There's a lot of traffic moving back and forth. Controllers try to tell you what's going on, but sometimes there's too many, and you can actually physically paint it, like in my case, the 650, and I know exactly where the traffic's at. It makes it a lot easier, gives me a sense of security flying in a congested airspace that I'm going to be okay.
John Twain applies his Cessna 182 out of eastern Maryland, always scanning the skies. But having ADS-B in has really been an eye-opener.
I was amazed by, when I got the ADS-B, how much more traffic there was in the sky that I had never seen. I did have a near miss here on the Eastern Shore about 10 years ago before we got the ADS-B. A plane came out of the wing shadow that I never saw, and we came within 200 feet of colliding. And I would have never had that situation occur had I had ADS-B.
ADS-B out will be mandatory for most controlled airspace by January 1st, 2020. ADS-B in for many pilots who've had close calls and avoided them ever since is indispensable.
So the ADS-B, it gives us all the traffic that's going to be out there.
All right, hopefully that came through okay. What's interesting about that, that perspective, I think, is just the increase in awareness that you're able to achieve by having that picture right there in your cockpit of aircraft all around. That is probably, I don't know, there's a lot of benefits in ADS-B, and we'll talk about them, but that one, just from the private pilot's perspective, I think has to be the most dramatic.
That's great. Thanks, Dan. So I'll just ask you one or two questions that have come through on the list here. So the first one that I had was, hi, Dan, you mentioned spoofing. Is that a serious issue for you? Yeah. Well, I think it is. Spoofing is a serious issue for all of us who use who use GPS, who depend on GPS. It is well known that there are bad actors throughout the world that do actively, regularly spoof GPS. They are either able to deny GPS service for a local area, or they will actually change the GPS signal so that the positions that are generated are erroneous. And it's simply the open nature of GPS that makes it vulnerable. And I wouldn't say that we've had a lot of examples of spoofing that we see on a daily basis in the US. So I wouldn't say it's a big problem. It's something we have to be prepared for. And I can tell you that our Department of Defense partners are very concerned about it. And we work air traffic
collaboratively, collectively with the DoD, the Department of Defense, and their military operations, and they are extremely focused on the risk. And so they do, as our partner, they pressure us quite a bit to make sure that we have the mitigations in place to ensure that there's a minimum amount of impact that occurs when someone either denies the service or intentionally degrades it or intentionally causes misleading information. The flip side of that I mentioned there too, the absence of GPS data is important as well, and we do not rely entirely on ADS-B and really anywhere. We monitor the status of the system regularly, and almost everywhere where we use ADS-B, we have some sort of a backup. So those things are extremely important to us, and we spend a significant amount of our engineering time and effort to make sure that the information provided by ADS-B to the air traffic controller is accurate.
Great, thanks very much, Dan. The next one I have here that's been voted up on our application, and like I said, please do continue to log your questions. It's pigeonhole.at and the passcode is NSS Conference. The next question we have then, Dan, is what is the time lag for ADS-B signal received verification process, ATC?
So I think what you're asking there is what's the latency from transmission to reception? It's a good question. I can't answer that right in the moment, but I'd love to be able to follow up and give you that you know, at a later date. I just don't have those numbers at the top of my head, but I do know that we have latency requirements for surveillance on the order of a second or 2 seconds. So everything's got to go through the system from detection to glass, you know, bore sight to glass, as they call it in the radar days, within a couple of seconds. So all the latencies have to fit within that link budget. But don't quote me on that. I'd prefer to be able to follow up and give you some more precise numbers.
That's great. Thank you, Dan. We'll be sure to follow up. Don't worry. So we have a top voted question here with 2 votes. So the next one is Mode C Veil applies outside controlled airspace. So transponder mandatory ADS-B in Class G. What criteria were used in determining where to apply these Mode C veils?
Yeah, I don't know the answer to that. It's a great question, but I am not involved with airspace design, so I really couldn't give you a good answer there. But like the other question, I do know the people I can call on to answer that question. So sure. I'll follow up.
We'll take a follow-up. Thank you, Dan. If you're happy to know, then there are a few other questions on here, but I know a number of them relate to the benefits of ADS-B, which, as I understand it, is what you're going to come to in the next section. So if you're happy to move on to the second half of the presentation, and I'll really keep encouraging people to continue to vote on the questions you would like to see, most like to see answered. And then when we come to the second question and answer session, we'll try our best to ensure that they are all covered as much as possible.
Keep asking and I'll keep trying to answer. I'll do my best.
Excellent. Thanks,
right.
Dan.
So yeah, what we're going to get into next is a discussion of first benefits, what we see as the benefits associated with ADS-B, and then also some of the challenges that we had to overcome in fully implementing ADS-B. So at the highest level here, we're able to get better and more coverage of airspace, more airspace covered by surveillance data, as well as really better quality data. And that leads to a number of improvements and applications that I'll get to here in a minute. We're able to better utilize the airspace by better covering it and to have more efficient operations in that airspace. And as it relates to infrastructure, I think that ultimately we're going to be able to reduce our radar infrastructure, which are very expensive systems, And on a airspace by airspace basis, ADS-B is much cheaper to install and to maintain than a radar system. Which leads to radar divestiture, which is an active program that we have going on. The program to reduce the number of radars that we have in the U.S. and their associated costs to own and maintain. So we're going to start with Gulf of Mexico. So this is a large body of water to the southern part of the U.S., between the U.S. and Mexico, and this area of the world is full of oil platforms, and there is no traditional surveillance in this area. No radar, of course, because it's difficult to put a radar system in the middle of the ocean. Not impossible. It's been done, but it's not something. It's not really the most efficient way to do things. So there's a lot of these helicopter operations that go from the U.S. to these oil platforms throughout the Gulf. And one of the applications that we applied very early on in the ADS-B program to show some early benefits was deploying ADS-B radios as well as associated weather sensing systems and VHF communications on oil platforms throughout the Gulf. And by doing that, we have areas where we have now controlled airspace for very large portions of the Gulf, which is really an interesting application. So those controllers along the coastline there can now see into much of the Gulf and now control that traffic where it used to be procedural. So just to describe a little bit of the impact there, since 2010, the number of instrument flight rules helicopter flights in the Gulf has increased by a factor of 3. While IFR helicopter flight times in the Gulf have been reduced by 10 minutes or more per flight. FAA estimates that these helicopters have avoided over 1 million nautical miles of extra flight distance. So pretty significant benefit that we deliver to these operators on a daily basis. Now, it's quite a challenge because these oil platforms are always, they don't stay in place for forever. So they're often being installed and decommissioned. So we actually have an active program to move this equipment around as these oil platforms move, which is, it's a program in and of itself, but we find it to be worth it. The benefits far outweigh the cost of doing that. So pretty cool stuff. So we are also in the process of rolling out reduced separation coverage areas in the U.S. So in Enroute airspace, the typical separation standard is 5 nautical miles. And we're in the process of implementing 3 nautical mile separation in large portions of Enroute airspace below flight level 230. So this has the effect, particularly in a really busy airspace, of being able to utilize airspace more efficiently. We have areas over the northeast of the U.S. which are highly constrained, really capacity limited, and our ability to safely move aircraft closer together produces significant efficiency benefits. So the first phase to expand availability of 3 nautical mile separation occurred in early 2020 at 2 key sites, Seattle and Boston. The FAA estimates potential flight time savings of $1.4 million a year from reduced conflict maneuvers. So one of the things that you can do when you have this closer separation standard is the conflict alerting that's in automation to say when there is a conflict. Well, there's going to be less nuisance alerts that occur. And when you have a resolution that's proposed by the conflict alert algorithm, they're more efficient in the way in which they can provide those aircraft back on track. So there's significant cost savings and better use of airspace when we're able to use ADS-B in this way. We've got 21 Enroute centers. We're in the process of rolling this out to maybe not all of them, because maybe not all of them really have a need for it, but the majority of them will have it within the next year or two. Okay, so search and rescue is really an interesting one where we see some significant benefits. And there's some really interesting stories, some good examples of how this has been seen in practice. So search and rescue is enhanced or improved when you can provide a precise location of a downed aircraft. And the more precise you can be, the less, the more quickly you can locate a downed aircraft. The FAA estimates that ADS-B equipped aircraft can be located 2.5 hours faster than aircraft without ADS-B in remote mountainous locations. So mountainous locations in this particular study in particular, you know, that's a big deal. Being able to locate someone 2.5 hours earlier can literally mean the difference between life and death. It's really significant. There was a recent story about a private pilot operating in the Bahamas who had to ditch over the ocean, and the radar coverage in this vicinity was only down to about 1,500 feet. So you can imagine if your last known position was 1,500 feet, there's a pretty wide search area that you're going to have to look to locate someone in that area. Using Aviation is a space-based ADS-B provider that has a service called Aviation Alerts, and we use that service and branded FAA alerts, but it's the same thing. What it does is it provides the last known location of an ADS-B equipped aircraft anywhere, really, and that can be provided to search and rescue immediately. So in this case, this particular last known position at 0 MSL, right on the ocean, was provided to rescue personnel who were able to very quickly find this downed aircraft and were able to save the life of this particular pilot. So it's really a tremendous benefit to be able to have ADS-B data for last known position as far down as you can possibly get it. So closer to ground level, the better. So I think this one's really interesting. So what's interesting is we did a study of looking at general aviation aircraft and comparing the accident rate for those that are equipped with ADS-B in and those that weren't. And what we were able to find is that the FAA has seen a 44% reduction in accidents for ADS-B in aircraft, ADS-B in equipped aircraft for the types of accidents we're studying. So for this particular population of aircrafts, or GA aircraft that are equipped with ADS-B in, the accident rate over a long time period was 44% less, which is really, really significant. We're talking about a significant number of reduced accidents, lives saved, and so on. It's absolutely huge. And I think this goes to the video that you saw earlier, the pilot's perspective, being able to see the complete picture, or in the case of a lot of places, just being able to see weather data through the flight information service is incredibly valuable and really makes the difference. So I mentioned radar divestiture. This is an active project that we have ongoing. I mentioned earlier all these many radar systems that we have deployed throughout the US. We're currently working on a radar divestiture project to eliminate 32 of those in the first phase of this radar divestiture project. And we're focusing in on these many systems that have multiple systems located very much in the same location. So they overlap a lot of their coverage. With that significant overlap, we're able to reduce one of those and still provide a complete surveillance picture because we have overlapping ADS-B as well. So we're in the process of doing that. There's significant cost savings that comes along with this, and the cost savings associated with no longer operating those systems and no longer having to tech refresh or replace them. We have an estimated benefit of in the hundreds of millions of dollars saved just for this first phase. And then beyond that, what we'll be looking at is for even more of our non-rural airspace radar systems, like our beacon interrogators that are located in Class D airports. A lot of those will be able to be eliminated as well because the traffic counts at those airports just aren't high enough to warrant both having ADS-B as well as a beacon interrogator. And the consequences of losing a radar for a little while or losing ADS-B, sorry, for a little while, just aren't significant enough to warrant the cost of having a beacon interrogator there. So over the years, we will continue to reduce our radar surveillance infrastructure. All right, this is just kind of a neat little example of a project that I happened to work a few years ago in a place called Southern California TRACON, which is a place that controls traffic for Los Angeles International. And this particular environment is particularly challenging for radar. There's tons of interference. There's lots of different radars competing, lots of buildings that cause reflections and distortion of the signal. And what we were finding there a few years ago is that this approach here, we have an aircraft coming in from west to east. They come around low altitude now, so the lower edge of the beam is starting to be interfered with by buildings. They come around to the south and circle around to land towards the west. And these aircraft, because of the distortion in the signal, radar signal, they get a sort of a stitching effect where they kind of wander back and forth. And so much so that they'll begin to be tracked into the path of other aircraft, which causes conflict alerts, causes go-arounds, it causes all sorts of undesirable situations. And what we were able to find is that when we implemented, since January 1st, when all the aircraft in this particular airspace are ADS-B equipped, this has completely resolved this type of issue. Now we get a once per second, very high accurate position delivered to the automation system, and it completely smooths out these sort of jagged tracks and greatly improves the quality of data provided to the air traffic controller. Just one last little point here. So we have a air traffic controller who's our union representative. So he works traffic at Houston, but he also is our representative to the ADS-B program. His name's Andrew Stakoviak, and he's our union representative of the ADS-B program. And he talks a little bit about the impact that this has had to the air traffic controller. Through the innovation of ADS-B, air traffic controllers see fused target symbols on their displays, updated every second, representing where the aircraft is instead of where the aircraft was. Previously, in a single sensor mode, controllers dealt with a 4 or 12-second latency that limited the controller's ability to tactically vector aircraft as safely and efficiently as possible, especially when the added complexity of weather exists. The ADS-B ground-based system and the aircraft equipage of ADS-B transponders has revolutionized the ATC real-time picture of surveillance in the NAS. Kind of an interesting perspective, because you can imagine if you're only seeing in the long-range environment a radar update every 12.5 seconds. That's a lot of time to elapse where you're trying to figure out where that target's going to show up again in the future. With ADS-B, you're getting it every second, and it really enhances the controller's ability to make good decisions in the moment. So just a summary of benefits. I've been over most of these. I think that you really can see both to the air transport side and the general aviation side, there's significant benefits. Really, honestly, on the general aviation side, I think those are the ones that really see the benefits for the way in which the system has been deployed today. And air transport sees significant benefits, but their benefits really come as we begin to develop more and more applications associated with ADS-B in and other things. So lots to come. All right. So I'm just checking on the time here, and I think we're doing okay. All right, I want to shift now to the last portion of my presentation here, where I'm going to talk about the challenges that we have had to overcome in this long process of implementing ADS-B, and what we did to overcome them. So first of all, early on in this process, we realized that even 10 years from 2010 to 2020 was going to be fairly challenging to get everyone who needs to be equipped. There were plenty of challenges that were raised by various constituents. So we had a industry and government call to action that brought together industry, government, and a number of associations together, all of our stakeholders really who had a stake in being successful here, and brought them together to identify the barriers. So what are all the problems that we envision to getting to 2020 successfully? And the Equip 2020 work group was formed. The original group identified 32 barriers that were grouped into 5 areas, and these were assigned to work groups. So I think the important lessons that we learned here early on was listen to all of the stakeholders and meet the challenges head on as early as you can and as aggressively as you can. And we were able to have some significant outcomes that really alleviated a lot of these barriers and really led to the success, right? So the success is in the successful implementation and completion of the mandate date. So some of the barriers that were identified by our carriers: ambiguity over which GPS receivers to purchase, limited availability of necessary equipment and resources, FAA resources for certification and approval. So getting all these aircraft through the process of being approved was a significant barrier, or perceived to be. General Aviation and the various associations identified equipment and installation cost, the performance, privacy concerns about the information about all these aircraft being aware, everyone being able to have access to all this information. User awareness and education, sort of getting the word out. Lack of metrics at the time of tracking who was equipped and how quickly they were equipping. Lack of clarity concerning viable navigation sensor options. Ability of FAA to maintain, schedule, and implement ground systems and capabilities to use ADS-B out. Need to establish and communicate aircraft manufacturer service bulletins, certification, on and on. So a lot of these are just around the process of getting there. How are we going to do all this? And so we again, this cross government, industry, and stakeholder group included many different, and really anyone and everyone was invited to participate here. So you had the airlines, aircraft manufacturers, noticed unions like NATCA, the associations like AOPA and ALPA. Really anyone who had a stake, who was interested in participating, played a part. So here's some of the key things that we're able to accomplish through this process. We published technical amendments to the final rule to clarify that equipment must meet performance requirements of applicable TSOs. We established this ADS-B out timeline exempted period. So there was concern around the position sources that some older aircraft were using that weren't always able to meet the performance requirements of the ADS-B equipment. We allowed those that applied and provided an equipment schedule were given a 5-year period to extend, so they're able to operate with this older nav equipment, older positioning equipment until 2025. They still had to meet the ADS-B rule, but they were able to do it with a less precise position source. We gave some relief to our sport and experimental aircraft, and we developed what was called a service availability prediction tool, which allowed insight into how the GPS system is working along a path that was intended to give insight as to how well GPS would be working along that path. We developed the tracking tools and trend analysis to know how we're doing. And we really worked on the processes of certification and prioritizing ADS-B over other things, and really worked to streamline approval processes to get all this equipment through the system. One of the things that came out of this process was a rebate program. So early on, we did realize that we had, there's 300,000 registered aircraft in the U.S. That's a huge population of aircraft. We didn't have to have them all equip. We figured that we probably needed about half of those to equip, because about half probably will never enter or rarely enter ADS-B airspace. So, but we didn't want everyone, 160,000 aircraft, 150,000 aircraft, waiting until the last year of the program, last year before the mandate, to equip. So the rebate program was really about getting people to act sooner. So it wasn't necessarily about driving the numbers up, although that was a nice thing, driving the equipage numbers up. It was about driving the equipage numbers earlier in the curve, so that the whole system, wouldn't be overwhelmed in the last few months of 2019. So we implemented this rebate program that gave $500 towards eligible ADS-B out equipment for up to 20,000 aircraft. And it was targeted at the lower end general aviation market. They had to be US registered, not currently equipped, and fixed wing, single engine, piston aircraft. So that was the target population. So we developed a process where you decided you wanted to implement this this program. You wanted to use the program. You had to reserve your rebate using an online system. You got a reservation code. You did the installation, and then you had to validate that the system, your onboard system, your avionics worked. And then you received an incentive code. Then you could claim your $500 rebate. So it was a process to make sure that that people actually followed through when they got these rebates. We weren't just handing out $500 checks. So the effect of this was really interesting, I think. What you see here is so Equipage numbers, monthly good installs over time by month. So 2015 through 2018, and you see the number of what we call good installs. Those are verified, properly functioning installations of ADS-B equipment over time. And you can see fairly low numbers in 2015. These are monthly installs in the $400 to $800 quantity range. Stepping up in 2016 as we started to get the word out, and then really stepping up in when the rebate was active. The rebate program was active. What's interesting, I think, too, first of all, that this did have the effect of shifting in time, so that we were able to get more people equipped sooner, not putting off to the very end of the time frame. It's interesting too that I think the whole machine of doing the rebate program, in other words, getting the word out to the equipment installers, to all the population of pilots, doing the marketing that was associated with this program, really helped not only equip earlier, but it kind of helped maintain this momentum. So you see into 2018, we're still seeing good numbers of over 1,800 good installs per month. So, what can I say other than that the program really worked? It was considered to be, entirely a success. So we did this in 2 phases in 2017 and 2019, roughly 10,000 rebates each of these phases. And here's what the numbers look like over time. So this is going back to 2018, so 2 years of monthly data, and it's kind of what you expect. I think earlier in this whole program, 2015, 2016 timeframe, I think there was probably some panic, that our numbers were not looking good, and if you projected those trends out, we weren't going to make it. You can see the target here. I mentioned 300,000. U.S. registered aircraft. We were really targeting about half that, and we now have roughly achieved that. But that was not always looking like it was going to be the case. But we saw some really good ramp up in the year of 2019, really around this April timeframe, and really stepping up through the year of 2019. And then we got past the mandate date. And things, as you expect, they do level off, but they're still increasing. So lots of people still equipping today and probably long into the future. So a lot of these aircraft, they don't need to travel into rural airspace all the time, but the benefits are there, and they're choosing to equip even long after they were required to, if they were in ADS-B rural airspace. So you can see the numbers continue to increase, which I think is really, really a good thing. So this is a different look at the same kind of data. So these are the 2 different links here. We have the 1090 link and the UAT link, and dual. There are some that equip with both. What's interesting is after January 1st of 2020, these UAT solutions really started to kick in. And what we saw here around that time was the introduction in the market of a really low-end, affordable unit that was targeted at the GA market, and a lot of them decided to use that product, and that really helped the numbers there, and continues to drive those UAT numbers up quite a bit, because it was just kind of the most affordable solution that someone could implement. As an aside to that, we also have had a lot of problems with that particular unit, and the way it was designed really had some problems with it, but you know, we've sorted those out as well. But the point is, those numbers continue to increase, particularly in that segment, that population. All right, make sure we got plenty of time for questions here at the end. We're looking pretty good here. Talk about, so policy for the unequipped. So what happens if an aircraft wants to access ADS-B airspace, but they're not equipped for whatever reason? Well, we do allow it. We do allow it if it's not routine, and for certain reasons. And we have a system that we developed called Adapt, where you can go in between 24 and 1 hour before your flight and make a request for an authorization for a particular reason. And if then it goes into this system that a lot of them are either automatically accepted, some are automatically rejected, depending on the reasons and the place where they're intending to fly and so on. And then there's some in the middle that require an actual person to review and evaluate. But then they're all, you know, returned yes or no. And mostly yes. I mean, we typically will allow, what we don't allow is people to abuse the system and try to do it every day or something. But if it really is not routine, we do allow access to ADS-B rural airspace for non-equipped if they use this system. So what happens if they are abusing the system, which does happen? So we do monitor. We have a system called the ADS-B Performance Monitor, and we detect non-equipped in rural airspace. We detect improper operation and non-performing equipment. And this is the system in the sky that will write tickets. Not really, but this will flag users who are not in compliance. And then our compliance part of the FAA will take action on that to investigate and to take the appropriate action, which, you know, could be quite a different range depending on the situation. It could be a letter of warning. It could be fines. It could be really even more severe than that, depending on what the situation is. But again, that's for the regulatory side of the FAA to take action on. We provide the tool that flags all these users that are not in compliance. Okay, and then finally for privacy, this is kind of an interesting thing. So we did have a lot of users out there led by the MBAA, which is National Business Aviation Association, who said, you know, we really don't want my customers don't want to be tracked. Well, we took this, we considered this problem and came up with a solution, which is a government-run website where you can go in if you want to request a private ICAO address. So what that means is that normally your ICAO address is linked to, you know, in the aircraft registry. You can look up exactly who is operating a particular aircraft. Well, if you don't want that to occur, you can go through this PIA system, request an address out of a block that is not linked to a specific airframe, and you can borrow, like a library, you can borrow this this ICAO address, do a maintenance action on your aircraft, and change the address. And then when you're flying, maybe you're a CEO that's going to a merger, and maybe you're I don't know, maybe you're a rich person looking to buy a football team in Dallas or something, and you don't want anybody to know that. But anyway, you can do that, and you can continue to check out these addresses periodically. I think every 30 days you can get a new one. And if you're committed to privacy, there is a route. So this is the method in which we do it. It is for the US only, but it is a method to address the privacy concerns of some of our constituents. All right, I'm going to do this very quickly so we have time. A couple things that we are looking towards. As I mentioned, this is really just the start. This is a foundation to build on. So we're continuing to roll out more 3-mile separations, so more efficient use of airspace. We're pursuing the radar divestiture program, which I mentioned, pursuing the search and rescue program so that we can continue to make ADS-B data available whenever it's needed. We're investigating what's called space-based ADS-B, which is a different method of getting ADS-B data. This was up through satellite link and then down through the ground. So theoretically, you can get, well, not just theoretically, actually, you can get position reports of ADS-B aircraft anywhere in the world, which is pretty cool. If you want to do, if you want surveillance of aircraft over the oceans, for example, and you want to improve your efficiency of operations across the Atlantic or something. So we're investigating this as a possible new service for particular applications. We have ADS-B in applications where we're investigating the use of what can you do with ADS-B information when one aircraft receives it directly from another. One of those things are automatic spacing from one aircraft to another, which will increase the efficiency of operations on our really capacity constrained routes. And our conflict probes and automation, we're enhancing the way in which we do this so that we can make the most efficient use of airspace in generating conflicts and resolutions. And really the future is wide open. I mean, we continue to find new ways in which this data, this system continues to enhance and improve our operations. So this is the things that we're looking at specifically for space-based ADS-B. There's these 3 flight information regions that we're investigating. So New York, Anchorage, and Oakland. So these are areas where we don't have surveillance, of course, but we're looking at the use of space-based ADS-B to see if we can do 5-mile separation, for example, in certain areas. Can we do closer oceanic separation standards? Can we do separation in the Caribbean, for example, when we lose a radar? So there's all these sorts of different applications. Can we provide surveillance over the Rocky Mountains where it's difficult to put, surveillance, ground-based surveillance infrastructure? We're looking at it over Alaska, where you have vast expanses of land without a lot of access to put in ground infrastructure. So we're looking at this. We have not implemented operationally anywhere, but it's something that has potential for the future. Okay, and in the end here, so we are already receiving significant benefits to the entire aviation community in the U.S. This system is foundational and really provides tremendous opportunity for the future. And January 2020 is really just the beginning of a really bright future for air traffic services with ADS-B as a key product there. So that concludes a very lengthy presentation. I hope that was interesting for you all. And now I think we can take some questions.
Fantastic, Dan. Thank you very much for that presentation. Some incredibly interesting information included in part of that. I know for me, not having a technical background, but 44% less accidents for ADS-B equipped aircraft from the survey that you guys explored that information. And yeah, really, really interesting to hear that. Also, I know Tom Gormley, the ADS-B technical advisor for the grant scheme here in the CA New Zealand. He'll have some, I guess, reference points or points that you've covered that there'll be the New Zealand perspective provided for on Thursday as well. So hopefully that's a good opportunity for people to learn about that also. We have lots of questions on Pigeonhole. A number of them have been voted up on, so many thanks for people for contributing.
Time for me to go then?
Indeed, indeed. Well, we'll do our best here and see how we go. We've got a bunch, so let's see how far we get. People have been voting on them as well, which is really helpful. So I'd encourage you guys to keep doing that. So thank you. So the first one,
it's after 5 o'clock here. So cheers, everybody.
Indeed. Great. So the first question for you then, Dan, is: do you think widespread mandatory uptake of ADS-B for general aviation supports not having ATC at smaller regional aerodromes as a way to strip costs out of the aviation sector?
So I think I need a repeat of that because I don't quite understand the question there. Do we think mandating it for GA would finish the last part of the question?
Yeah, so do you think widespread mandatory uptake of ADS-B for general aviation supports not having ATC at smaller regional aerodromes as a way to strip costs out of the aviation sector?
Interesting. So it's not something we've studied. We have a number of airports that are either contract or not controlled. We do not currently mandate ADS-B in those areas because the benefits mechanism that we studied when we launched this program did not show a significant benefit there. So we did not pursue that type of application. It doesn't mean it isn't something that we should keep our eye on for the future. In other words, I think the benefits there are probably small, and maybe the costs are high. So that's the cost to the aviation community, the general aviation community. So I think that's something that we didn't go after initially because of that. Smaller benefits, higher cost, and we're really trying to be nice to our general aviation communities and minimizing the mandatory aspect of the system, and really trying to go after the benefits and getting equipage that way. So if we could, show and demonstrate what the great benefits are of ADS-B, that's when people are going to, they're going to equip. Now, what we hope to happen is that will drive up equipage without requiring it at smaller airports. Now, what does that, to what that actually means, whether or not we could, reduce the amount of air traffic control at some of those places, I'm not clear on that. I don't know the answer to that, but it's probably something that, has benefit, but it's not something we've studied.
Okay, great. Thanks very much, Dan. The next question I have for you then: is there any ability to filter ADS-B for covert operations such as police or military, whereby they can still be tracked by the ATS system but not broadcast to third-party companies?
Right. So that is a really, really big deal in the U.S. There's a lot of scrutiny on that very question, and it's a very good one. So we all know that if you are broadcasting ADS-B, you're going to be visible to anybody with a cheap receiver. It's very inexpensive to buy your own ADS-B receiver and see anybody out there. So the way in which we are pursuing that very issue is allowing our law enforcement and military to turn off ADS-B for operations they determine to be important to maintain operational security. And we also control the distribution of data out of our systems when it is identified as what we call sensitive flight. So we have a process where law enforcement and military will submit to us, hey, this flight over this time frame should not be distributed, and we have that. We maintain that list, and then we protect those, and we don't distribute that data out. That would not be good enough by itself if everybody was just broadcasting ADS-B, for the reason I mentioned earlier. So there needs to be, if you really want to protect sensitive operations, you have to have a way of turning it off. So our rule does have an exception for military and law enforcement.
Great, thanks very much for that answer, Dan. The next one, and again, not being a technical expert here, I know you've covered this already, so feel free to refer back to some of the comments you've already made on it. But this one is about radar divestiture. And with the enhanced surveillance coverage of ADS-B, will both non-GNSS contingency surveillance and non-cooperative PSR surveillance be retained?
Okay, good question. And you know, I might just kick this one over to the divestiture project lead if he's still on, Mr. Devlin Maxwell.
Hey, Brad, I'm still here. Don't listen in. Dan, can you hear me?
Yep, we can hear you. Go ahead.
So
you can take that one.
Yeah, I followed the question. So, like Dan said, the radars are going to play a vital role in surveillance services traffic for a long time. And I think the question was around that ADS-B and the primary radars that we will retain. Like Dan said, we got a lot of them across the country, and we're looking at 32 really across an overlapping area. So I think if I understood the question right, it's yes, we're going to retain that primary backup capability where we need it to ensure the air traffic gets the services that we need to move traffic.
Hey, Devlin, it was a little bit hard to hear you. I'm not sure. Maybe your bandwidth is a little bit interfered with, but so I'll go ahead and take a shot at as well to make sure everybody can hear the answer. So we will be retaining both cooperative and non-cooperative surveillance systems. We're going to retain cooperative beacon interrogators and wide area multilateration for backup to ADS-B. And we're going to retain our non-cooperatives to provide a weather product in terminal areas and for coverage of non-equipped aircraft and so on. So we're going to retain both types. We're just going to reduce the amount that we have of each type because we want to reduce the overlap.
Great, thanks, Dan, and thanks for the efforts of your colleague as well to contribute to that. Sorry about the little bit of a patchiness and sound quality. The next question for you then, in regards to space-based ADS-B, space-based ADS-B is most reliable with diversity installation, top and bottom antennas. Will diversity be mandated for those airspaces if implemented?
Well, that's a great question. And I'll try to have a short answer here. This is something we're studying extensively. We have an operational evaluation going on in the Caribbean, which is Miami Center performs air traffic control for the Caribbean islands off to the east of Florida, and we have a service volume of space-based ADS-B that we're experimenting with right now. And what we find is that the update rate of the space-based ADS-B is really not sufficient for a number of reasons. We're not getting updates frequently enough to do 5-mile separation in that region because of diversity. Not all aircraft have diverse antennas, top and bottom. There is also competition with spectrum congestion. Anytime you get high 1090 environments, you get interference and you miss updates. The satellites there also lower down in latitude. There's less satellite coverage, so it's less reliable. In other words, there's a number of reasons that it might not work for every application that we're investigating. Now, your question is really about would we mandate both top and bottom mount, and it is something that Canada is looking at. I do believe they are looking at mandating top mounted antennas because they're really using space-based ADS-B today operationally over the North Atlantic, and they're looking at it for other applications as well. I do think they're looking at a mandate. I don't think the US will. And part of that is just because, you know, we really do try to stay away from mandates. I mean, they're really difficult for the industry to swallow, you know, to afford, particularly in this kind of, you know, pandemic environment where airlines are struggling to survive. We are not going to put a mandate that requires them to spend more money on equipment right now. It's just not going to happen. So the US is not looking at that kind of thing. What we're going to do is figure out where it works and where it doesn't. So what we do find is when you're looking at space-based over, say, the North Atlantic, you get better coverage, there's less interference. update rates are not required to be as high to get good the required separation of whatever it is, 15 miles, 17 miles or whatever. So what we're really looking for is finding the applications where it works, not changing aircraft to make it work in more places.
That's great. Thank you, Dan. So yeah, we've absolutely loads of questions here. Doing our best to just go firing the ones to you according to top votes. I feel a little bit like an X Factor judge here, scanning the page. But we'll carry on with one or two more. I know we're coming a little bit shorter on time now. So the next question for you. Are there any plans for the FAA to use any other aspect of space-based ADS-B other than Aireon alerts?
Oh yeah, well, so Aireon alerts is just one product that we do use. We are looking at it for a number of other applications. We are looking at it, like I mentioned a minute ago, for contingency. So like when you lose a radar, if you had space-based, you could still do tactical separation instead of reverting to procedural. And we're looking at that at the Caribbean. We're looking at reduced separation over the North Atlantic. We're looking at it in the Pacific and in Alaska, sorry. Looking at it there for contingency. In the Pacific, we're looking at it for increasing the efficiency of operations into some of the Pacific islands that don't have any surveillance coverage at all. So we do procedural separation there, and they would benefit from surveillance, tactical separation instead of procedural. So we are, and basically, I mean, to cast kind of a wide net here, we're looking at it for every application where it might be beneficial, and we're trying to thoroughly test the extent to which it will work or not work, and then zero in on those things where it really has benefit.
Excellent, thanks, Dan. The next question, a slightly more operational one. How would an airborne pilot know if his equipment was continuing to meet the performance requirements of the applicable TSOs?
Yeah, that's a good question. I don't think I can answer that one. I honestly don't know. So as you'll notice from my presentation, pretty much oriented towards the the ground side, not the air side, and I am not a pilot, so I don't know the answer to that question.
Sure, that's no problem, Dan. We do have some other perspectives being provided later in the week in our webinar, so maybe an opportunity for that baton to be taken up at that stage. So all these questions that we have will be held for the duration of the conference until Friday. And as I mentioned, there's not going to be able to get through all of the questions today, but we will be endeavouring to get answers to people afterwards. One or two more questions then for you, Dan, just before we wrap up. Thanks very much for your time. How many applications have been made for PIAs?
It's not very many. I don't know the exact number, but it's less than 50. So it's not a lot. It's not a lot.
Okay.
It's less than we expected. I'll put it that way.
Yeah, great to know. And then, is the reduction of accidents that you mentioned in your survey more an indication of the type of flying of those who have added ADS-B, or were there a lot of mid-airs?
I think it's a function of the population of aircraft that were studied and the types of operations that they do. Lots of VFR. So there's see and avoid mode, where the risk is that they're just not going to be able to see somebody coming, like they're just in a bad blind spot or whatever. So I mean, I think it's just a function of the aircraft population that was studied. And we do focus in a lot on those general aviation pilots in making sure we're providing a benefit to them. So that's the best answer I can give to that one. I don't think I know that much more detail about it, but that's what I can tell you about it.
Sure. Thanks, Dan. And that leads on somewhat nicely to the last question that I'll ask you for the session, which says, hi, Dan. While ADS-B in is obviously a safety benefit, does it enhance or replace the need for pilots to see and avoid? Does the FAA see, detect and avoid, replacing see and avoid in time?
I think I think so ADS-B-in really enhances the pilot's situation awareness, but it really doesn't change the operational nature of the pilot and the controller's responsibilities. I think it just improves the ability of the pilot to understand the situation that he's in.
Okay, yeah, great, thank you. Right, so at that point we will finish with the question and answer session. Dan, a very big thank you for your time today. In a moment, I'm just going to pass over to Director of New Southern Sky, Steve Smith, for a few closing comments. But just a reminder to folk with us on the call that tomorrow, 7 p.m. New Zealand time, we will have Andrew Anderson from IAOPA providing an Australian perspective on their ADS-B transition. And then on Thursday at 7 p.m. New Zealand time, we'll have Tom Gormley, the ADS-B technical advisor for the grant scheme, giving a New Zealand perspective on best practice and a number of other things. So do hope you were able to join us for that, and a very big thank you for joining us today. I'm just going to pass over now to Steve Smith to give us a few closing comments and end the session. Thank you, Steve.
Thanks, Lorcan. Can you hear me okay? All right, Dan, you've just made history by being our first NSS Conference virtual speaker, and what a great job you've done of it. It's been a privilege to listen to you. Thank you so much for sharing your journey in the United States to ADS-B capability with us. It's a fascinating story, and it's a story of great success. And we're really trying to build on the lessons learned and the advice that you've given to us. So we really appreciate it. And also, the way you've handled those questions, thanks for being so completely honest with us and really giving us insight into the thinking behind some of the decisions that you've made. It's really good to see that what you've done is evidence-based at every step. So that's really impressive. Look, Dan, we've thoroughly enjoyed having you along today. It's been a great start to our little 3-day webinar series. And thank you and Amy and the rest of the team for the fantastic support in getting this underway and making it such a successful start. We really appreciate it, Dan. Thanks very much.
Yeah. Thanks for having me, and thanks all. I really appreciate it.
Cheers, everybody.